In this video, we are going to look at the CSEC Math January 2024 Paper 2, Question 8. So now in Question 8, Part A, we have the diagram below shows the graphs of two functions on the same pair of axes. The lines G and H are perpendicular. So this is the line G here. This is the line H. We can see 90 degrees between the two lines. So they are at 90 degrees to each other, meaning they are perpendicular. Now, the first question we have is to determine the equation that represents the line G. So this is the line G, and we want the equation of the straight line, which is in the form y is equal to mx plus c. So in order to find the equation of the straight line G, we would need the gradient and the y-intercept. Now, I can see that we have the y-intercept as 3. That's where the line touches the y-axis. So all I would need to do is work out the gradient of the line G, because I already have the y-intercept. So I can write down that C is equal to 3. And what I could do is form a triangle here where I can get my change in y and change in x. Now we can see as we move from left to right, this line is going upwards. Therefore, it has a positive gradient. Therefore, my change in y would be positive. And we are going from the origin, which is 0 here, all the way up to 3. So my change in y is just 3. And now my change in x, which is the horizontal distance, is from 0 to negative 6. So the change in x would just be 6. So now my gradient, and the symbol for the gradient is m, would be the change in y over the change in x. And my change in y is 3. And my change in x is 6. Therefore, my gradient is equal to 1/2. So now I can write the equation of the line in the form y is equal to mx plus c. And I know the y-intercept is 3 because that's where the line touches the y-axis at 3. And I know my gradient is 1/2. So all I have to do is put in those values. So for m, I'm replacing that with 1/2. And for c, I'm replacing that with 3. And this is the equation of the line G. So now moving on to part 2, we want to determine the equation that represents the line H. Now remember, the line H is perpendicular to the line G. And therefore, if we know the gradient of the line G, then the gradient of the line H would just be the negative reciprocal of the gradient of the line G. So I will call the gradient of the line G m1, and we work that out to be 1/2. Therefore, the gradient of the line H, I'll call that m2, has to be, well, the reciprocal of 1/2 is 2 over 1, which is just 2. And then you change the sign, so that'll be negative 2. So if you multiply m1 times m2, you would get 1/2 times negative 2, which is just equal to negative 1. So if two lines are perpendicular, when you multiply their gradients, you would get negative 1. So we see that the gradient of the line G is 1/2. Therefore, the gradient of the line H has to be negative 2. So that when we multiply two gradients, we will get negative 1. And that's because they are perpendicular. So now that we have the gradient of the line H, we just need the y-intercept for the line H. Now we are not seeing where this line touching the y-axis, so we'll have to work it out. So in order to work out the y-intercept for the line H, we would need the gradient and any point that the line passing through. Now we can see that this line H is passing through 4 on the x-axis, and the coordinates of this x-intercept will be 4 on the x and 0 on the y. So I'm going to put using m is equal to negative 2, and the point the line passing through, which is 4 on the x and 0 on the y, which is the x-intercept of the graph. Now remember, this could be any point that the line passing through. So now this is my x part of the coordinate, and this is my y part of the coordinate. The equation of a straight line is in the form y is equal to mx plus c. And therefore, I can replace this y with the y part of the coordinate, the x with the x part of the coordinate, that the line passing through, and then the m is the gradient, replacing that with the negative 2. So the only unknown will be c, which means we can solve for c. So for y, I'm putting 0. For m, I'm putting in negative 2. And that's been multiplied by x, and x is 4. And of course, c is my unknown. Now 0 is nothing, right? So 0, negative 2 by 4 is negative 8, plus c. We transfer the negative 8 across, it will turn positive 8. So therefore, c is equal to positive 8. So if you write the equation of the line in the form y is equal to mx plus c, and we put in the values for m and c, we would have y is equal to m, which is negative 2, times x, plus c, which is positive 8. And this would be the equation of the line h. So now for part 3, we want to determine the coordinates of the point P, and we want to show all working. So we've seen that P is the point where the two lines intersect. Now I wrote down the equation of the line G, which is the y is equal to half x plus 3, which we found in the first question. And then we have the equation of the line H, which we just found as y is equal to negative 2x plus 8. So in order to find the coordinates of the point of intersection of these two lines, we'll have to solve these two equations simultaneously. So I'll write my first equation, which is y is equal to half x plus 3. And my second equation, which is y, is equal to negative 2x plus 8. This is my equation 1, and this is my equation 2. Now we have an interesting situation here. The value for y in both equations would be the same, as well as the value for x in both equations will be the same, because that's the point at which the two lines intersect. So if y is equal to half x plus 3, and y is equal to negative 2x plus 8, it would simply imply that a half x plus 3 is equal to negative 2x plus 8. And therefore, you could bring all like terms together. So the half x together with the negative 2x. So we have a half x. I'll transfer the negative 2x across the equal sign. I will turn positive 2x. I would leave the positive 8 on the right-hand side. And I'll transfer the positive 3 across the equal sign. I'll turn to negative 3. So now a half x plus 2x is just 2.5x. And 8 take away 3 is just 5. So now we have 2.5x is equal to 5. So we have this 2.5 here is being multiplied by x. And remember, we want to solve for this x. So if we transfer 2.5 across the equal sign, the operation will change from multiplication to division. So we'll get x is equal to 5 divided by 2.5. Now we could go and type this into the calculator and work it out one time. Or we could convert this to improper fraction. 2 by 2 is 4 plus 1 is 5. So we'll have 5 divided by 5 over 2. We'll change this divide to multiply. So we have 5 multiplied by, and invert my divisor. So invert this. So the 2 comes on top and the 5 comes below. And now this is something we could work out. I could simply put this 5 over 1 and we could cancel up. So I'll do that. So I'm writing the 5 over 1 like that. So that's equal to x. And this 5 will cancel this 5. 5 into 5, 1, 5 into 5, 1. And all we remain with is 1 by 2 over 1 by 1. So the answer is just 2. So we're going to have x is equal to 2. Now, a coordinate has an x component and a y component. All we found so far is just the x component. Now we can substitute this value for x into any of the two equations. So now equation 1 reads y is equal to half times x. So think about it as a half times 2. That's just 1. So you're going to put 1 plus 3, which is 4. So y is 4. Or you can use equation 2, where we have y is equal to negative 2 times x. And remember, x is 2. So that's negative 2 times 2, which is negative 4. And negative 4 plus 8 is 4. So it doesn't matter which equation you use. You're going to get y is 4 when x is equal to 2. So I'll just substitute x is equal to 2 into, and let's use equation 1. Equation 1. So we have y is equal to half x plus 3. So y is equal to half times x, and x is 2. And we know half of 2 is 1. So y is equal to 4. So that means the coordinates of P will just be 2 on the x and 4 on the y. And that would be your answer. All right, so moving on to part B, part 1, we have to write this quadratic in the form a x plus h in brackets squared, so that's our perfect square there, plus k. So this is just completing the square. So I'll write the 4x squared, take away 24x plus 31. So now the first step would be to get rid of this 4 in front of this x squared. So in order to do that, I have to factor out the 4, which means to divide everything by 4. So I'm going to write 4, put some brackets like that, divide 4x squared by 4 and get x squared. 24x divided by 4 is just 6x. And then we're going to have 31 divided by 4. So let's write that as 31 over 4. Because, if you divide this, you're going to get a remainder. So I'll close my brackets. Then I'm going to set things up for my perfect square. So brackets like that. I'm going to bring back down this x. The sign here is negative. I'm going to find half of this 6, which is 3. I'm going to write back the 31 over 4. And I'm always going to take away this number here squared. So that'll be 3 squared. Let's put back the brackets now with the 4 on the outside. So what I have to do now is to work out this 31 over 4, take away 3 squared. So I'm going to write 4, put back everything. All right, and I'll do this part on the calculator. So I'm going to have 31, use the fraction button, over 4, take away 3 squared. And I'm going to get negative 1 1/4. Prefer to write this as an improper fraction. So I'll press second function, fraction button, so I get negative 5 over 4. So I'm going to write here negative 5 over 4 and close the brackets. So now to get rid of this big brackets here, remember at the beginning, I divided everything by 4 to pull this 4 out. So now I'll multiply everything by 4 to get rid of this big brackets, right? Which is this expansion. So when I multiply this 4 by the x take away 3 in brackets squared, I cannot say 4 by x and 4 by 3, right? Because of this square sign here. I'll have to, work out the perfect square first and then expand. But, we don't want to do that. So we're going to leave it as 4 times x take away 3 in brackets squared. And then we'll multiply the 4 by the negative 5 over 4. And if you look at what's going to happen here, 5 over 4 multiplied by 4, which is 4 over 1. And the 4's will cancel out each other and you remain with 5. So, of course, it's negative, so you're going to get negative 5. And now I've written this quadratic in this form where a is 4, h is negative 3, and k is negative 5. Now moving on to part 2, we have on the axis below, sketch the graph of 4x squared take away 24x plus 31, indicating the coordinates of the maximum/minimum point and the y-intercept. So since we are going to sketch the graph, I'll write out the quadratic as y is equal to 4x squared take away 24x plus 31. Now the y-intercept will be 31 because you obtain the y-intercept when x is equal to 0. So if I were to substitute x is equal to 0 into this equation, if I put x is 0 here, any number by 0 is 0. So this will take this will be 0. If I put 0 for x here, this will be 0. And the only thing that remains is y is equal to 31. So that's my y-intercept, 31. So now I'm going to recall my answer from part 1, which is here. So I wrote this quadratic in this form. So I'm going to write that back. 4 times x take away 3 in brackets squared, take away 5. So we're going to have 4 times x take away 3 in brackets squared, take away 5. And the important thing about this form is that the turning point, you just have to change the sign on this number here. All right. And then this negative 5 outside here will be the y component of your turning point. So this here will be x component, change the sign on it, so you get positive 3. And this number outside here will be a y component of your turning point. So now to address the maximum or minimum point, well, seeing that the number in front of x squared, which you call the coefficient of x squared, is positive, the graph is a minimum. Okay, so my turning point, as I said, change the sign in front of this number. So from negative 3, it will be positive 3. And this will just be y component, negative 5. is a minimum. Let's put min. All right, so we have the turning point. I already explained to you that this number here is your y-intercept. And y-intercept is 31. So now looking at the axes that they gave us to sketch this graph, they didn't put any number in. So we'll have to number this. We need to cater for 31 on the y-axis, somewhere up here. Positive 3 on the x-axis, somewhere here. And then we have to go down to negative 5, somewhere down here. So I'm just going to use my ruler to put some markings on the line. And now we'll just put some markings for the y-axis. All right, so I'm done with my ruler. As you can see, what I did was use 1 centimeter spacing. Okay. So for the y-axis, seeing that only have 4 centimeters here, I'll just let every 1 centimeter be 5. So here will be negative 5. Here will be origin 0. Here will be positive 5, positive 10. Remember, I need 31, right? So 15, 20, 25, 30. And here will be 35. So that covers 31 for the y-intercept. And for the x-axis, I'll just count here as 1, 2, 3. That's all I need. Okay, so remember, this is a minimum curve. My turning point would be 3, negative 5. So if I draw a line from 3, come down like this, intersecting with a line from negative 5, that would be my turning point. And my y-intercept would be positive 31, which is about here. And remember, as I estimate, is just a sketch. So now what I need to do is make a parabola where here has the minimum point, goes up, touches this point. Of course, try and make it symmetric about this point. All right, so let's see. All right, so that's half of it there. And the other half here. Not perfect, freehand. All right, so this would be your sketch of the graph showing the turning point and the y-intercept. All right, so now I'll just indicate the coordinates at the turning point. So I'll just put x here for it. And I'll put the coordinates 3, negative 5. And remember, that was a minimum. All right, so minimum point. And then the coordinates are the y-intercept. So that would be 31 on the y, but 0 on the x. So that would be 0, 31. All right, so now the last part of the question, which is part 3, is to state the equation of the axis of symmetry. Now, this graph is supposed to be symmetric about this turning point. Therefore, the axis of symmetry will be this vertical line passing through the turning point. And that vertical line will pass through 3 on the x-axis. So the equation of the axis of symmetry would just be x is equal to 3. So for part 3, equation of the axis of symmetry is x is equal to 3. And that will bring us to the end of this video, so stay tuned for the next video on question 9.